Hello, in today's video we will be looking at how to simplify surds for GCSE Maths. What are surds? A surd is an irrational root of a rational number. These two words, irrational and rational, are important. We'll come back to them in a bit. An example of a surd could be the square root of 5, as this is equal to 2 point something, and this something is likely to last forever. Another example could be the square root of 11, equal to 3 point something, and again this point something is likely to be infinite as well. However, a number such as the square root of 25 is equal to 5.0. That's it. It stops right there. So when we have a number that can be defined in a finite number of decimal places, we call this a rational number. But when we have one that cannot be defined in a finite number of decimal points, we call this irrational. Hence, a surd is an irrational root, because it goes on forever, of a rational number, since 5 is a rational number. So what can we do with surds that will help us simplify them? If we take a surd, such as the square root of 12, we can write this as the square root of 3 times 4, since 3 times 4 is equal to 12. This can then be written as square root of 3, square root of 4. So writing this is equivalent to writing this. We could also write the square root of 12 as the square root of 24 divided by 2, or root 24 over root 2. However, we cannot write it as the square root of 10 plus the square root of 2. These are completely different things. So let's try to apply this multiplication method to our first example. So we've got the number, the square root of 18. We can write this as the square root of any of its factor pairs. Its factor pairs include 1 and 18, 2 and 9, 3 and 6. However, the only one of these which includes a square number is 2 and 9, since 9 is equal to 3 squared. So we can write the square root of 18 as root 9 root 2. But we can simplify this even further. As I just said, 9 is equal to 3 squared. So the square root of 9 is equal to 3. So we can write this as 3 root 2. And this is what we classify as a simplified form. Next, our example is the square root of 45. Let's write this down, root 45. Next, let's write out its factor pairs. We've got 1 and 45. Then we've got 3 and 15. Then we've got 5 and 9. And that's it. Again, the only one of these pairs that has a square number in it is 5 and 9. So we're going to be using that pair again. So let's write this out with the square number first, as it helps when we simplify. Then the 5, the other number, the root 5. And as we just said, root 9 simplifies down to 3, and then we keep the root 5. So there's our simplification of root 45. Next, we have root 50. So root 50, let's write out its factor pairs up here again. We've got 1 and 50, 2 and 25, 5 and 10. And that's it. And out of these three pairs, the only one with a square number is 2 and 25. So we can get rid of the other two. And as per usual, we write our square number first. So root 25, then root 2. And since the root of 25 is equal to 5, we can write this as 5 root 2. There's our simplified form of root 50. Next, we have the square root of 200. Don't be worried. Big numbers like this can seem a little bit daunting, but if we stick to the method that we've used so far, it won't be too hard. This time, instead of writing out all of the factor pairs, since there are likely to be a lot, let's just write out all the square numbers and up to 12 squared, and work out which is the largest that can go into 200. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and 11 squared is 121, and finally 12 squared is 144. And if we go through this list backwards, we can stop when we find one that is a factor. 144 is not a factor of 200. 121 is also not a factor of 200. And here, 100 is a factor of 200. And its factor pair would be 2. So you can write this as root 100 root 2. And this simplifies down to 10 root 2. So there's our answer. Finally, we have one more question. The square root of 363. Let's use the same method that we did before, of writing down all of the square numbers that we know. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So again, going through this backwards, we can rule out 144, but 121 does go into 363, with the other in the pair being 3. So let's write this out. Square number coming first, root 121 root 3. This is equal to root 11 root 3. There we have it. That is how to simplify root 363. Finally, here's a little challenge for you to try at home. Use the method that we used in the last two questions, since it's a large number, and leave what you think is the answer down below in the comments. Thank you for watching. I hope you found this video useful. If you did, please leave a like and subscribe.